Good afternoon, everyone. Good morning, not afternoon. Good morning. Jeez. So, welcome back. And what we're going to do is we're going to talk about the Pythagorean theorem today. So, we're still talking about trigonometry. The very first thing that we talked about is Rule 180, which applies to every triangle, solving for any angles. Now we're going to get into the Pythagorean theorem. So let's just read our goals for today. Our goal is to identify the hypotenuse in a right triangle. So we're going to label and figure out which one is the hypotenuse, because that's going to make our solutions correct and the use of our formula correctly. We're going to use a Pythagorean theorem, and there's a formula for that to determine the length of unknown sides of a right triangle. Okay, so as we saw in the introduction, triangle with a 90-degree angle is called a right triangle. So in the next few lessons, we're going to be talking about right triangles, and we're going to focus on right triangles. So a lot of all of those questions involves a right triangle, and a right triangle has one 90-degree angle in it. So right triangles have special qualities that other triangles do not. So that we're going to explore this part here. The longest side of a right triangle is called hypotenuse. The hypotenuse is always the side directly across from 90-degree angle. So last time we said that when you have a triangle and then you see this square part there, that tells us that angle is 90 degrees. 90 degrees. And we said that's 90 degrees because this is your initial arm, that's your starting arm. So if you were here yesterday, we did that activity. This is the starting arm, and then rotating that way, that makes it 90 degrees. Just to show the people who weren't here yesterday, what we do is when we measure the angle, we put the starting arm, which is this one here, right at the 0, and then this corner here goes at the hinge. Like when you think of the door, it's like a hinge of the door or the corner. So this is where you're starting at 0, and then we're turning right here, and then this is where we're stopping. This is the start, and then we're turning this way, and then this is where we're gonna end, and that ends at 90 degrees right there. Okay, so just for the people who weren't here yesterday. So this is going to be 90 degrees. When you see this square here, automatically understand that that angle is 90 degrees. So once we identify which one is 90 degrees, the side that's right across from the 90 degrees, right across from 90 degrees, is called the hypotenuse. Okay, what's so special about the hypotenuse? Okay, so hypotenuse is right across the 90-degree angle. 90-degree angle. And what's great about the hypotenuse is it is the longest side in a triangle. That's why the hypotenuse is super special, because the hypotenuse is the longest side of the triangle. Okay. We could probably do an activity later on that one, okay? But for now, we'll just take our word for it, right? That the hypotenuse of the longest side. So it says here, what we're going to do in this part, it says label the hypotenuse. We're going to label the hypotenuse. So which one is the hypotenuse in this triangle? So you have the three sides. You're going to locate, okay, this is my 90 degrees angle. And where it opens up, where does this 90 degree open up? It opens up right here. So the hypotenuse, I'm just going to put HYP, kind of abbreviates the word hypotenuse, HYP. Okay. Now let's take a look at, is everybody okay with that one? It's okay. Now, they tried to trick us a little bit, right? They turned the triangle around, and then they're gonna say, okay, now which one's the hypotenuse? This one here. So this is a 90 degree angle, and then right across from it, that's the hypotenuse. Is that okay? It's important that we identify which one is the hypotenuse. Now this one here, they make us kind of think a little bit harder in this one. Well, not so much harder. Where is the hypotenuse in this one? The south side? Yeah. That's a nice way of saying that. So if this is my 90 degree angle, hypotenuse is right across. Hypotenuse. Okay. And then turning the triangle around, this is the 90 degree angle. Where is the hypotenuse? This side here, right? Okay. Now that seems like it's such an easy activity, but it's an important one. Okay. So what we're gonna do is we're gonna get into the Pythagorean theorem. What does the Pythagorean theorem say? The Pythagorean theorem states that the squares of the length of the two shorter sides, okay, which one's the two shorter sides? We know the hypotenuse is the longest side, right? This is the longest side. They said the squares, okay, what does it mean by the squares? Yeah, the squares of the lengths. So this is the length of the two short sides. These are the two short sides. So if we square this, 8 squared, plus if we square this one, I'm going to bring it closer, that is going to equal to the hypotenuse squared. So these two together, squared plus another square, will equal to the longest square. Okay, so let's see. We're going to try to use some examples to do that. So the Pythagorean theorem can be used to calculate the length of the missing side if we know the length of the other two sides. Okay. So this, like I said, is only used for a right angle triangle. Okay. I'm actually gonna give you the formula over here, okay? So the formula for the Pythagorean theorem. Okay. Maybe you've heard this before, okay? Pretty sure some of you have, right? Have you heard of a squared plus b squared equals to c squared? Anybody have heard of that one before? Some people, yeah. So when we look at this one in here, a squared plus b squared equals to c squared, that's gonna represent a, b, and c are represented in the side of a triangle. So the c squared is the hypotenuse. So the c squared, the one by itself, is the hypotenuse. And then the a and the b are the two short sides of right triangle. Okay. Think of this as like you got the two short sides together to make one long side, right? So, okay, I'll let you finish copying that part down and then we'll get started. So far, so good? Yes? Okay, so we're going to use the Pythagorean theorem to figure this out. Now, what do we know? These two are the two short sides, so we can call them one is A, one is B. Is that okay? We're going to call the two short sides, the two short sides, we're going to call them A, and then the other one is B. And then if this is my 90-degree angle, right across that, that's the hypotenuse. So that we're going to call that hypotenuse our C. Hypotenuse is always the C. Okay. I'm going to start off with the formula. So A squared plus B squared equals C squared. A squared plus B squared equals to C squared. What do we have? A, what are we going to replace the A by?
5 inches.
The 5 inches. So I'm just going to put 5 instead of 5 inches so that we don't have to worry about that. We'll do the units at the end, okay? So A is 5, and then what do we do with 5? We have to square it, right? Exponent 2 plus B. Okay, well, what do we replace the B? We're going to replace it by the 12. So we're going to put 12 in here. 12 squared equals, what do we replace the C? Well, the C would be the X. That's X squared. Okay. So stop right there. Give you a little bit of a moment to just kind of think about what we just did there. Okay. So at the beginning of our course, we talked about solving equations, and this is where it's going to be useful, solving equations. We're going to solve for the x. Find out what the x is. So meaning, have the x alone. Well, how can we get the x alone? Well, we can go 5 squared. What's 5 squared equal to? 5 squared is 25 plus 12 squared is 144 equals to x squared. Okay, is everybody okay with that one? So 5 to the exponent 2, you could try that on your calculator. It should be 5, give it a try. 5 exponent 2 Yeah, did everybody get 25? Yeah. And try 12 squared. What's 12 squared? Yeah.
12 is going to equal 144.
Yeah, 144. Did everybody get 144 for 12 squared? Okay. Now, what are we going to do next? What does that say? We're supposed to add them up. Okay, so what's 144? Add the 25 to that. 169. So 169 equals 2x squared. Okay. We got up to this part here. We are trying to solve the x. Okay. Have the x alone. Well, how can we get the x alone? We have to get rid of the squaring. To isolate it. Yeah, to isolate it. Yes. So how do we get rid of the squaring? What's the opposite of squaring? Square root, yeah. So this is an equation. So what we're going to do is I'm going to take the square root of the left or the right side. What I do on one side, I got to do it on the other side, right? So square root of x squared. So the squaring and the square rooting cancel each other out. So we are left with x. Now we're going to use our calculator in here. It says, what is the square root of 169? So let's give it a try. What's the square root of 169? So give it a try on a calculator. It's probably been a while since we used a square root button. $13? 13, okay. So what we said here, the x is 13. So now going back to that one, the x is 13. 13, what's the unit for that? 13 centimeters. So now we're going to put the inches. Inches. We're going to put 13 and then the inches as our unit. 13 inches. Okay? Well, that's kind of nice, right? 13 inches. Now you look back over here. Okay, so this one here is going to be 13 inches. Now, does this triangle make sense? Two short sides, and then the hypotenuse is the longest side. Is the hypotenuse the longest side? Yeah, it's 13. Now, before I get into that, the next example, I want to show you something, okay? It's nice that we solve this algebraically. Okay? So what I'm going to do is I'm going to try to recreate this triangle. Okay, I'm going to try to recreate the triangle. I'm actually going to turn it this way because it's not going to fit. So I'm going to start off with, okay, I'm going to try to recreate this triangle with the exact measurement. Start off with I need a ruler that's in inches. Oh my goodness, no. All of my rulers are in centimeters. Do you have an inches?
This side.
Oh, okay.
Would that work for you? It's too short.
It's kind of short.
Short.
Is that a inches?
Yeah.
Oh, perfect. Is this yours? Oh, awesome. Thank you. Okay, yeah, you got the inches ruler too. Okay, so what I'm gonna do, I'm actually gonna use the desk again, okay? I'm gonna use the desk again because it doesn't fit on the paper. Okay, I'm just gonna remember to erase it later. So 12 inches. 12 inches. 12 inches is here. That's 12 inches, right? 12 inches right there. What else do we? So 12. Can everybody see it? 12 inches. What else do I need to do? Okay, I need to make a right triangle here, and then that's gonna be 5 inches. So I'm gonna make sure, I'm gonna use my protractor so that I can make a right triangle, measure my 90 degrees. So this is my starting arm, and then I rotate, that's my 90. Okay, it's kind of faint, but that's okay. And I'm supposed to create 5 inches this way. Okay, so going to this picture again, this is 12 inches. Everybody could see that, right? 12 inches, and this is 90-degree angle right there that I measured, and then I measured this to be 5 inches. Okay, what did we calculate? The hypotenuse is from this to there. Okay, so I'm just gonna draw. I'm gonna draw a line from there to there, but I need an extra long piece.
Use one of those books.
I gotta use one of those books. Correct.
Yeah, but Atlantis book is a little longer than
I'm gonna use one of these. Okay,
Jacob might use for duster.
the duster. That works, right? That's long enough. Okay, I'm gonna go this way. Being resourceful is awesome. Okay. Oh, that one. Okay. Well, according to our calculation, how long should this be?
13.
13. Okay. Now this is the moment of truth. The ruler only goes up to 12. Okay, so that's up to here is 12. And then this one should be 1 inch. That's 1. Can you see 1 inch?
Yes.
Oh, 1 inch.
And the crowd goes,
And it's shaking. Yeah, there you go, 1 inch. So that is 13 inches. Yeah. So we calculated it 13 inches, and I actually physically drew the triangle, and it does measure 13 inches. Now, which way would you rather do the solving? Would you just solve it by calculation, one way, or should I draw every question? Probably this is a little bit challenging, right, to draw every question. because it's not gonna fit all the time. So I usually take this time to really show it to everybody, right? Because sometimes, yeah, we go through the process of solving, but we never really talked about like what does it really look like in an actual measurement. Okay, so I just wanted to show us that. So from now on, well, thank you very much for lending me this part.
Kind of, she helped me do it
Yeah.
to understand it, but just we did it the same way.
Oh, the
but
other
it's
way.
backwards.
Yeah, let's just flip that.
So you don't really technically need to do this one, you just have to do it.
Yeah, that's okay. That's perfect. Okay, now let's get into this one. We're gonna, this is probably our last example for today. We're gonna take it nice and,
Each. This is 1 inch.
Yeah.
oh,
12 inches.
do you need a calculator?
Yeah.
Oh yeah, I got extra.
There's a 12 inches. Centimeter. This is a meter.
Okay, I got an extra calculator here. Okay,
Yeah, this is more clear. There's a
dollar store, yes. Okay, now let's take a look at the example number 2. We're gonna take it nice and slow so that everybody understands this. So here's a right triangle, right? If this is my 90 degrees, right across from the 90 degrees is called the hypotenuse. Right across from 90 degrees is called the hypotenuse. And the formula says a squared plus b squared equals 2c squared. Okay. I like how they did a squared b squared equals to c squared because it's just the alphabet, right? A, B, C. The c is going to be always the hypotenuse. And then the A and the B are the 2 short sides. Okay. So if going to my triangle, that's why it's important to identify the hypotenuse, right? Because if we can't identify the hypotenuse, then we might be plugging in the wrong information in the wrong place. So hypotenuse is the C. Then these two are going to be the A and then the B. Now in this case, A and B, they could be interchanged, right? So we can call this our A and we can call this our B. Okay. Can you see A and B? A and B are connected right on the 90-degree angle here. The A and the B are the ones that are connected to the right angle there. Okay. So let's do the substitution. So A is 19, so I'm going to put 19 squared plus B is 21, so 21 squared equals C, or that would be our x squared. So 19 squared plus 21 squared. I'm gonna try to do that on a calculator. So 19 to the exponent 2. That's gonna give me 361 plus, okay, 21 squared, so 21 exponent 2 is 441 equals to x squared. Okay, so I'm gonna wait and just to make sure everyone is pretty much on this stage. Yeah. Good.
Are we still rounding off, like, because of the numbers carry, because then you get the carryover of it? It actually goes to 28.31, but the next
Oh.
number to it is 32.
I think you're ahead of me, but can I get to that part where you are? You're ahead of me. That's okay. I just want to make sure everyone's in this stage. Yes? Okay, so the next part is 361 plus 441 is 802 equals to x squared. Okay, now we're going to have the x alone, so get rid of the square. So this is where we're going to take the square root. Okay, so x, got to go square root of 802. So square root of 802. Okay, so this is where you were talking, what you're talking about with rounding, right? So we're going to round it off to 2 decimal places here. So 28.31, but then right after the 1 is a 9. The next, because the number after the 1 is over 5 and over, then it would be rounded off to 32. 28.32. And then this is a time also where we have to put in the unit. So it's 28.32. Everything is in meters, so that's going to be 28.32 meters. That's our final answer. Let's put it up here. This is going to be 28.32 meters. How's that? Is that okay? Yeah. Okay. I'm going to write right there. Tomorrow, what we'll do is we'll continue on. Okay, I'll let you finish writing that. Now I'll show you what the next topic tomorrow, continuation. So when you look at this part here, we're going to get into a situation where what's missing here, we got the hypotenuse. We're missing one of the shorter side.
We're missing A.
We're missing the A. Yeah, we're missing the A, one of the shorter side. So that's a similar strategy, but slightly different way. We'll continue on with that. So we have example 3 to finish tomorrow, example 4, and then we're gonna do the application 5 and 6, and that will give us, okay, hopefully there's no technical issues. We can get started right away. Yeah, we'll finish it off tomorrow. Okay, good. Well, have a great day, everyone, and stay nice and warm out there because it's going to be -30.